So almost all the types of graph we discussed. One graph is left. This is graph number 1, graph number 2, graph number 3. This should be graph number 4. Graph number 5 we will discuss now. Graph number 5. So in this graph, this is also the displacement time graph, the graph between the displacement and time. This graph is also a displacement time graph. On the y-axis, there is a displacement s, and here there is a time t. S is the displacement, t is the time. Now, if the graph is supposed like this, if the graph is supposed like this, okay, this type of graph you have. If we have this type of graph, then what we can conclude from the graph? Do you know what is acute and obtuse angle?
Yeah.
What is acute angle?
Angle which is below 90 degrees.
Very good, very good. I think now you have the idea. So I told you that in case of this angle is representing the slope. Okay, this angle will decide the slope. This angle. If you have remembered, so you will take this angle.
Yeah.
This angle will be more than 90 always. This angle will be more than 90 always. Okay. If this angle will be more than 90 means this, if this angle is theta, so I can say this theta is lying between 90 degree and 180 degree. This theta must be greater than 90 or less than 180 degree. Okay.
Yeah.
Now, initially, you can say initially, this body have some displacement initially at t is equal to 0.
Yeah.
Okay, so we can conclude initially there is some displacement. Some displacement is there. Now, with time, the displacement is decreasing or increasing? With time. Okay. Take this point. First point I have taken this. Okay. So I want to check at this point what is the displacement. So at this point, the displacement is this. Okay, suppose this is S1. So as the time increases, we are coming here. This is T1. Suppose this is T2. This will be the displacement, and this will be the graph, and this will be the displacement S1. So can you tell me S2 is greater or S1 is greater? S1.
S1.
S1 is greater. So with time, the displacement is decreasing now. You can see here.
Yeah.
Okay, very good. So with time, displacement is decreasing. Okay, now we'll discuss the velocity time graph. Acha, can you, I am just defining some of the uses of the displacement time graph. Okay. So with the help of the displacement time graph, the position of the body can be determined at any point of time. Okay.
Yeah.
And the slope of the graph will give you the velocity. The slope of the displacement time graph will give you the velocity. Nature of the motion can be determined whether the displacement is decreasing or whether the displacement is increasing. Okay, so few points we should, I think, write for the displacement graph, displacement time graph, uses of displacement time graph. Uses of displacement time graph. So first thing, we can get the position of the body. The position of body can be find out at any time. You can see the example, means at any time with the help of the graph you can find what is the position with respect to the time. There is a particular position, particular displacement. Okay. Secondly, slope of graph will give velocity. 2 points. I will write only 2 points. After this, we will discuss the velocity time graph. Velocity time graph. So velocity time graph, first graph is like this. Here is velocity v, and on this x-axis there is time. So velocity diagram, first graph is like this. This type of. So what can we conclude from this type of graph? With time the velocity is zero, na? This is the 0 point. With time the velocity is zero. Velocity is 0, 0, 0. With time means the body should be at rest. Okay, so the conclusion of this graph, if this type of graph you will have, then what you will conclude from this type of graph, body will be at rest. Why if someone can ask why you are saying that the body is at rest? Because if you will take the time, for suppose you are taking this time, suppose time t1, t2, as the time passes the velocity velocity is zero, velocity remains zero. Time is passing but the velocity is zero. It means the body should be at rest. Okay. So the conclusion is body is at rest. So this was very simplest of all. Second type of graph. Okay. On y-axis velocity, here is time. Now the graph is something like this. Now what can you conclude, Rayyan, from this graph? Can you tell me your conclusion? Means what things you can conclude from this graph? First go at t is equal to 0. At t is equal to 0, there is some initial velocity. And now with time, that initial velocity is changing or remain constant?
Remaining constant.
Very good, very good. Means initially the body is having some velocity, but after that the body is moving with constant velocity. So the conclusion, for this graph, you can write initially body have some velocity. Have some velocity with time. The body is moving with constant velocity. Okay, because this velocity is a particular value of velocity. That means with time, the velocity remains same. You can take any time t1 and t2. For this time also, the velocity will be this. For this time also, the velocity will be this. So velocity is not changing with time. With time, the velocity is not changing. Another graph. This is velocity. This is time. If this type of graph is given, and one more thing, okay, fine. If this type of, and one more thing that I want to tell you, the slope of velocity time graph will give you the acceleration. Okay.
Okay.
So write down here slope of Vt graph will give you acceleration. So slope of velocity time graph is equal to v by t, and change in velocity divided by change in time is acceleration. That is equal to acceleration. If this type of graph you have, now we will solve this graph with the help of the slope. This angle, if suppose is theta, will this theta changing with time, or this theta is remaining constant?
It's changing with time.
No. This theta will never change with time. No?
So
You can
like
see this is a straight line. This
angle.
is straight. This straight line will be always a straight line. And this theta will always be theta. Now I told you that slope of the graph. The slope of the graph will be given by tan of theta. So if this theta will not change, this tan theta will not change. This tan theta will remain same. So what does it mean? Slope remains same. Okay. Slope remains same. Or you can say slope is constant. What is the meaning of the slope is constant? Slope is acceleration. Slope is acceleration. So you can say acceleration is constant. So you can say that in this graph, from this graph, we can conclude that the body is moving with constant acceleration. Okay. The body is moving. I am giving the reason also. I am not writing directly. I am giving reason why the acceleration is constant. The body is moving with constant acceleration. With constant acceleration means uniform acceleration also, you can say. Can you give me one example of a body moving with constant acceleration?
With constant acceleration.
We have done.
If a car is cruising, or like.
No. That is okay. That is fine. But Real life example I want. Means I want to say any example.
Mm.
Can you give? Means if you will say that a car is moving with a constant acceleration, that is not the example. I want to say basically the acceleration under gravity. Oh, sorry, the motion under gravity is an example of constant acceleration, no?
Yeah.
If the body is moving under only gravitational force or motion under gravity, that is the example of uniform acceleration or constant
Yeah.
acceleration.
Yeah.
Okay. Please write down all these graphs with neat and clean.
Yeah.
Okay.
Okay.
Because this is given in your syllabus and I am teaching this according to your syllabus. Okay.
Mm.
So accordingly, you have to make notes properly.
Mm.
If you will make notes by yourself, then your understanding will increase. Okay.
Mm. Yes, sir. Wait, I start from here, yeah? Should I write from number 5?
Yeah, actually, this is the graph that is
Yeah.
included, that is included in displacement time graph. Okay. So I
Okay.
have not completed this graph, so you should write from here in the last class.
Mm. Sir, can you scroll down?
Okay.
Sir, can you go back to the thing?
This one?
Yeah, this. Thank you.
Okay, I am zooming in actually.
Oh yeah, you can scroll down now. It's fine. To
Okay.
the velocity. Yeah, there. Sir, can you scroll down? Sir, can you scroll down? Hmm.
This one completed?
Oh no, not yet. I'm writing it down.
Okay, okay, okay. Right.
Okay, sir. Write it down.
Okay. Now we will discuss next graph. Next graph is like this. Graph number 4. Velocity here on this axis, and here is time. If suppose the graph is like this, okay, if the graph is like this, in this case also, if I am talking about the angle theta, okay, see this graph first. This is the graph. So basically at t is equal to 0, there is some velocity of the body. So you can say initially there is some velocity. Initially the body have some velocity. Body have some velocity. You can see here at t is equal to 0, the body have some velocity. Suppose this is v1 velocity. Body have. Now with time the velocity is increasing or decreasing? With time. Increasing. Very good. Increasing. Okay. So velocity is increasing. Now we will calculate the slope of this graph. So to calculate the slope, there is a requirement of angle with x-axis. So this will be the x-axis. Okay. Actually, I am drawing this line parallel to this line. I am drawing this line parallel to this line. A dotted line I am drawing. This dotted line. So can you just tell me this theta angle will, we should use some different color. Can you tell me this theta angle will change with time or will remain same with time?
Will remain same.
Remain same. So what is the slope of the graph? Slope of the graph is tan of theta with x-axis. Tan of theta with this axis. With this is tan theta. Slope will be tan theta. So this tan theta will be constant value. So slope is constant. Slope is not changing. What is the meaning of slope? Slope of the velocity time graph is what? Acceleration is the slope of velocity time graph. So slope is the acceleration.
Yeah.
And acceleration is constant. So this is also the example of uniformly accelerated motion. The body is moving uniformly accelerated. Okay.
Yeah.
Body is moving with constant acceleration. You can write simply. Constant acceleration. Now last graph. Graph number 5. This is for body A. This is for body B. This is A body. This is B body. The graph of body A is this. The graph of body B is this. We have to tell which body will have the more acceleration. A or B? And I
B.
want the reason also why the acceleration will be large for body A or for body B. With the help of slope, you should try. Okay, just okay. I am explaining this, then next question you should try.
Okay.
There you go. Okay. So see here. First, try to find out the angle of this graph. This angle is suppose theta 1. Can you tell me this angle is suppose theta 2? Can you tell me theta 2 is greater or theta 1 is greater?
Theta 2.
Very good. Theta 2 is greater. So theta 2 of the is greater than theta 1, and theta 2 is for body A and theta 1 is for body B. So you can say that tan theta 2 will also greater than tan theta 1. And what is tan of theta? Tan of theta is slope. So you can say slope of body A, slope of graph A is greater than slope of graph B. So what is the slope of velocity time graph? Acceleration. So you can say acceleration of body A is greater than acceleration of body B. So simple.
Yeah.
But you should know that this concept theta, tan theta is known as slope. Slope is tan theta, na?
Yeah.
Slope is equal to. Do you know what is sine theta, tan theta, cos theta? Okay.
Yeah, little bit.
Okay, little bit.
Yeah.
If I am asking, for example, otherwise there will be very problem if you don't know this. This is a triangle. I have to tell you this separately, I think. If this angle is theta, if suppose this triangle, a right angle triangle A, this is A and this is B, this is C. If I am saying find the value of sine theta from this triangle in terms of the side, can you find sine theta? If you don't know, then we will discuss, no problem. Sine theta. Do you know means have you studied trigonometry in your maths?
I did it, but yeah, I did it like last year, so I don't remember. I did it.
Okay, so I am not saying I am not going in deep. Actually, I am just asking the basic things. I am not saying that solve any means inequality or solve any question. I'm just asking very simple and very okay. So sine theta na is basically okay. So someday I will tell you this separately. Okay, it will take time. Otherwise, this much of trigonometry, I think you should know. So there are some values in trigonometries, like if I say 10 of 45. So these things I see you should know. 10 of 45 degree equal to 1. If I am saying, okay, I am starting with sine, okay? So do you know na, there is sine in 10, sine in trigonometry, there is cos in trigonometry, there is tan in trigonometry. At least these things you should know, na? Okay.
Yeah.
Sine, cos, tan. And there are something else. Okay, sine 30 degree is. Do you know what is the value of sine 30 degree? 1/2.
Yeah.
If I am saying sine 60 degree, root 3 divided by 2. Okay, no problem. So separately I have to take a lecture on this. So basically the acceleration of the body A is greater than the body B. Why? The slope of the body A is greater than the slope of body B. Okay, now one question.
Yeah.
One more question. Two graphs are given. Okay. You have to tell which two bodies are given. Okay, just a minute, just a minute. The graphs of two bodies are given. Body A, the graph of body A is this, the graph of body B is this. You have to tell which body will have the more acceleration. Okay? Let's try.
B.
Okay, we will check. We will check. Okay, I am just taking the solution with this color, okay? Blue color.
Yeah.
So that you do not get confused. Solution, blue color. Solution is from blue color. So all the things I will write will be the part of the solution. So what we will do, we will just see the angle with the x-axis of both the graphs. So this angle is suppose theta A. Now check the other angle. This angle is suppose theta B. So now can you guess which angle will be greater, theta A or theta B?
A.
Okay. So now can you tell me the answer? Which will have the more acceleration, A or B?
A.
A. Because the theta A is greater than theta B, means tan theta A will be greater than tan theta B, means slope of A will be greater than slope of B. Means what is the slope of velocity time graph? Acceleration.
Yeah.
So acceleration of A is greater than acceleration of B. In this way you have to solve because a neat and clean solution. So from where you should note down? From here now?
Yeah.
Okay, write down properly. I will give you the proper time, okay? Don't hurry up.
Okay, sir, I wrote this down.
Okay. A means acceleration.
Yeah. Okay, sir, I wrote this down. Okay, sir, I wrote it down.
Rayyan, okay, Rayyan completed. Okay, Rayyan, if you want to ask any question regarding this, I think there should be no doubt, okay?
No, yeah, this
So
one.
this is from here means the velocity and time graph is completed. Now there is very one small topic that is acceleration time graph.
Hmm.
And after finishing the acceleration time graph, okay, we will move forward, okay?
Hmm.
And please attend the classes regularly and revise the notes properly. And in the end, what is the meaning of in the end? In the end means whenever you will have the examination, means when you will go to the examination hall, believe me, you will feel that there is a difference in you in physics.
Hmm.
I'm not talking about the other subject because I don't know what you are doing in that, but here you are doing good. In physics, you are doing good. I am analyzing that you are doing good in physics. So like